Welcome to this explainer. Today, we're doing something that is going to fundamentally shift your mental model of AI. For most of us, when we interact with a tool like ChatGPT, it really feels like we're talking to a thinking, reasoning entity. But today, we're prying open the black box to transform that perception, and we're going to reveal AI for what it truly is, a statistical prediction engine.
Here is our roadmap for today's factory floor tour. We'll be looking at the illusion of intelligence, the 5 processing stages, why AI seems so smart, the predictable ways it fails, and finally, how to use LLMs safely.
All right, part 1, the illusion of intelligence, and how we're shattering our expectations of AI. Look at this contrast here. On the left, we have our natural human expectation. We just assume that AI is like a super smart colleague, thinking about a topic, researching an answer, and carefully writing an essay for us. But the mechanical reality on the right? Totally different story. It doesn't actually know what it's saying. It only knows what words tend to follow other words. It is literally just a statistical prediction engine of astonishing scale. And as we're going to see, it has some profound limitations. Moving right into part 2, the 5 processing stages, taking us from prompt to paragraph. We're going to reverse engineer the machine here. What's absolutely wild is how these 5 totally mechanical stages, tokenization, embeddings, attention, prediction, and generation, combine to give us these mind-blowing capabilities. Every single step is actually incredibly simple in isolation. The magic you see, that entirely emerges from stacking them together. So step 1 is tokenization. When you type a prompt, the AI doesn't read words like you and I do. It physically chops them up into fragments or tokens. Take the word tokenization itself. It might get split into token and ization. Honestly, this perfectly explains why a massive supercomputer will fail at something as simple as counting the letters in a word or spelling something backwards. It literally never sees the whole word, just the chopped up pieces. And that brings us to a really crucial point. The model's entire universe is built from these fragments. It never encounters a word as a single unified thing with a fixed meaning. It builds its entire simulation of understanding purely from statistical patterns between these chopped up pieces. And hey, this isn't some temporary glitch that engineers are going to patch next week. This constraint is baked right into the fundamental architecture of the system. Okay, stage 2, embeddings. Here, math takes over. Functions convert those chopped up tokens into vectors, which are basically just long lists of numbers. Notice how the system learns statistical relationships, meaning tokens that show up in similar contexts get assigned similar numbers. So the mathematical vector for king ends up sitting right next to the vector for queen, but structurally way far away from a word like banana. What we get is literally a geometry of meaning. It turns relationships between words into vector math, like king minus man plus woman equals queen. It's an incredibly elegant concept. But, and this is a big but, you have to remember this vector is just a statistical average of every time the word appeared in the training data. It's mushing together financial banks and river banks into one mathematical compromise. It's math, it is not actual human understanding. Stage 3 is attention. This is where the transformer architecture works its magic, updating every single vector at the exact same time based on its relationship to every other token in your prompt. Say you type, explain quantum computing. It calculates the relevance between quantum and computing, mathematically shifting the meaning of the word quantum based on the surrounding context. It knows you don't mean quantum leap. Then we hit stage 4, prediction. After mapping all those vectors out, the model just assigns probabilities to guess the single next word. If your prompt is the capital of France is, the stats heavily favor Paris at 95%. London gets a small chance at 4.9%, and a completely random word like penguin gets a tiny fraction of a percent. It just picks the most likely next guess. Finally, stage 5 is generation. It locks in the word Paris, tacks it onto the sentence, and the whole guessing game loops all over again. We call this an auto-regressive loop, and it repeats hundreds of times. There is no internal outline, no grand plan it's following, and definitely no fact-checking module making sure it's right. It is literally just spitting out a statistically plausible response, one single token at a time, until it hits a stopping condition. Which leads us to part 3, why AI seems so smart, or the paradox of next token prediction. So here's the paradox, right? If it is literally just guessing the next word, why does it sound so incredibly smart and human? Well, it comes down to these 3 interacting factors. First, the sheer massive scale of the training data. These models have ingested a huge chunk of all digitized text, so they've seen pretty much every rhetorical structure in existence. Second, transformers are amazing at maintaining context across thousands of tokens, keeping arguments perfectly on topic. And third, human language is just highly structured and predictable. When it writes, "I look forward to hearing from you," it's not reasoning, it's just retrieving the absolute most statistically common way we humans close our emails. Now let's get into part 4, predictable ways AI fails, and really understanding the architecture's flaws. Because we know exactly how it works now, these failures aren't random, mysterious bugs anymore. They are predictable features of the system. First up is confabulation, or what a lot of people call hallucination. When the model hits a gap in its data, it doesn't say, "Hey, I don't know." Its only job is to generate the highest probability next token. So it confidently guesses a totally fabricated response, making up citations and historical events simply because they fit the expected statistical shape of human writing. Second is sycophancy. If you feed it a biased or leading premise, the AI is architecturally wired to be a total yes man and amplify your framing. Why? Because in the billions of human conversations it trained on, humans usually accept conversational premises and build on them. Statistically speaking, disagreeing is pretty rare, so the model just plays along. Third is the illusion of depth. These models are fantastic at stringing together structural rhetoric that sounds incredibly profound. They can spit out philosophical musings or complex coding structures using the absolute perfect vocabulary. But the depth? That is entirely in the reader's interpretation. To a non-expert, it sounds super authoritative, but it actually contains zero genuine insight. And honestly, that makes it highly dangerous if you lack the expertise to evaluate it. Fourth, we run into context window limitations. Every single model has a hard memory limit for a single prompt. As of right now in 2026, that caps out at around 2 million tokens. If you dump a massive legal brief in there that goes over that limit, it physically has to drop the earlier instructions. It simply forgets because the attention mechanism can only juggle the tokens that actually fit inside that window simultaneously. And finally, the compounding error problem. Think back to that auto-regressive loop from stage 5. Because the generation is sequential, if the model makes one single bad guess in sentence 3, that false token is now part of the context for sentence 4. It then has to try and statistically justify that false premise, which cascades into a completely fabricated argument. It just snowballs. Let's wrap things up with part 5, using LMMs safely and reclaiming your agency. Now that we know the true statistical reality of the machine and its structural flaws, we have to redefine our role. The judgment call is entirely on you. The model cannot self-correct, and it has absolutely zero access to external reality. If you use it to draft a contract, you have to read every single clause. If you code with it, you test every function. You are the ultimate editor and fact-checker here, because this incredibly powerful tool has no internal monitor to check itself against the real world. I want to share a quote from the source text that just perfectly shatters this illusion of intelligence and grounds us right back in reality. The model itself knows nothing, understands nothing, and believes nothing. Any intelligence it seems to have is purely borrowed from the humans who wrote the text it was trained on. So, I'm going to leave you with this final thought and question to carry into your very next prompt. If the AI doesn't actually know the truth, who is responsible for finding it? Well, the true thinker in this equation has to be you. Thanks so much for joining me on this explainer, and I really hope this completely changes how you interact with the digital world. Catch you next time.